All right, good afternoon. So, what about the quiz? How was it? What, you're smiling? Was it too long, is it? Were you not able to finish? Okay. ठीक है, we'll grade it leniently. But the idea was negative marking because I made it multiple choice. So you guys are coming, so you're sincere. But those who don't show up, I mean, a lot of them don't show up, but they will just see somebody's answer and mark it. So I don't want that tendency to happen to guesswork. But if, how many questions were you able to finish? 3? Everybody was able to do 3? Yes? Okay. All right. So we'll grade it leniently. But I thought first 2 problems were just from the notes. So it wasn't, you should have been practiced with this, and the last 2 were not too much work in that sense. But never mind, I'll show this before your mid-sem so that you can get an idea. You know? So we'll grade it leniently, so don't have to stress about it. Okay, so coming to lectures. So we are now about to finish. So like you saw, we had 1 introduction, 3 lectures on regression, 5 on support vector machine, and then 4 on distance. 2 we have already done, where we first lecture was on exemplars, defining the distance metrics and figuring out a representative data point. Once we got a representative data point, then hey, कुछ different ले आना. Okay. So once we got the representative data point, we built the basic classifier and you did some questions. Now we are focusing on 2 lectures on clustering, which is unsupervised in the sense you don't know which groups you want to put into. Earlier it was a classification problem where you knew where to put into different groups, right? So that is the goal. Before I go forward, I'll just remind you the material which is already there. So these 2 lectures are there. And then class scribble, of course, recording gets uploaded. So Thursday you will do 2 problems on clustering. One is basic scatter computation, which you will learn today. And the second is more of a real life problem from genome sequence, which I created from my research. We used this in one of our research papers, so I thought it will get you practice. And then there's a numerical where you'll code 2 different clusters. So 1 hour each will probably take. Hai na? So lecture today is one part of the clustering, tomorrow is another part of the clustering, so that completes that part. Moving on to the offline material. Supporting material, I have uploaded a PDF. Distance metrics, I had already told you, I have uploaded a clustering survey where you can tell how to choose different clusterings. Then practice problems, now they are about 5 or 6 distance based problems I have uploaded. This you will be able to, this is slightly different from what we will do in class or you will do in tutorial, but try to attempt that from tomorrow onwards or maybe Thursday onwards. After you have done the tutorial or once you finish the lecture, then you can practice it. Hai? So that's the practice of that. Then moving forward, there are 2 homeworks which we are going to refer on scatter today. So this is, so all material is up. Hai? So now coming to the class. So we'll start distance, but just to give you an idea where we are finishing. So we are starting distance based, like, you know. So today is this, we are at week number 6. Huh? So week number 6 with 17th Feb we are starting. So yesterday was off, hai na? Monday was off because of, anyways we had decided to, Tuesday we'll have lecture 12, Wednesday we'll have lecture 13, and Thursday we'll have tutorial lab 7A and B. So this kind of finishes my material, but Chandresh wants to start a week after the break for this part. So I'm going to use the next week and give you some more. So this is more about fun, hai na? So don't have to stress about. So this is 24th Feb. So Monday what we'll do is, Monday we'll do the quiz for those who were absent. So the funny part is that 213 students, 191 of you gave the quiz, 20 said they are somewhere engaged, and there are 2 people who have not told me anything. So I don't know what they will do. So if they don't tell me, then they'll get 0 out of 10. It's 10 marks, right? So what we'll do, Tuesday, we'll go over the practice problems. We'll pick some set of practice problem from all 3 topics, regression, SVM, and this. So the TAs will go over with you the difficult problems in case. So this is kind of a revision for your exam. Hai na? And what I'll do is Wednesday, I'll take a real life example and go over with you where machine learning is being used. So this is more to fill the gap so that you learn something also and we don't waste time. And then Thursday for the lab, we'll just focus on the survey paper. So you can, let me know about your survey paper, how far you have gone. I think most of you have shown me the papers except few of the batches. So those who have not shown, they can show me, otherwise how you're structuring it. Now that you've identified these 3 to 5 papers, it's more about abstracting the ideas out and making an outline of the paper. So you can show me how you're structuring it, what sections you're trying to put and saying this part will come from here, this part will come from here. Is that okay? So this is how we're going to finish. So this is an extra week which I'm trying to use it since I've been given a time, although I can make this free also for you, but this is for your own good. Is that okay to keep you engaged for this week? Is everybody fine? Okay, all right. Hey, what happened to the other CSC girls? They're coming. You guys were not there before the quiz. You were preparing for it last week, huh? I was noticing that I thought, girls are more sincere than boys. At least it's CSC. Okay, so let's start. So what we'll do is we'll first define something called as a scatter or a scatter matrix. And then you will see where this is. So I think I'll write very little because I have worked this out on my notes last time when I taught. So it's all there. Can you see at the back, Deepak? No, you can't see? Okay. So I'll probably make it bigger. You have to tell me that if you can't see, I'll make it bigger. And I don't think I'll write very little. So is that clear now? Okay. So what we'll do is we'll define something called as a scatter and play around with it. And tomorrow you're going to see that the algorithm which we're going to develop around it, the clustering algorithm which we called this as unsupervised learning, will use this as an underlying theory in building the algorithm. So that is why we have to understand this. That's the goal. Okay, so given a data matrix X, let's say, you've got a n cross d matrix where these are data points. So it could be d-dimensional. For example, if it's 2-dimensional, it will be just 1, 2, and then you've got number of data points. We define as a scatter matrix as xi minus mu and xi transpose minus mu transpose. This can also be written in this form, which I work out in the homework. But let me just first make you understand what the first notation means. So what scatter intuitively means is how much are the data points by the English name scattered away from the mean value. When I say mean value, the centroid value. Now the centroid, how many ways can we find a centroid? Give me some examples from the last week. Squared, 2 norm, centroid. Medioid is when the data point is, when the point is coming from within the data set. I'm talking about a centroid which is separately defined from the set of data points. You can compute it by squared 2 norm or just the 2 norm or the 1 norm or the squared 1 norm. There are many ways of doing it. Remember, we were focusing on 2 norm and 1 norm specifically. And the squared 2 norm centroid was the mean value. Remember the theorem? The squared, the point which minimizes the square Euclidean distance in 2 norm from every point is the mean of that, which we proved in the theorem. So here mu is referring to any centroid. But for the sake of this work, we'll focus on mean values mostly because that's the easiest to work with. But how well are the points scattered away from this centroid value? We want to put this in form of a one matrix, and then we'll say we'll define the scatter matrix, and then we'll take the diagonal elements and define the scatter. Now this relates to something called as the variance and the covariance of the data, right? Variance is how the data is spread out among itself, right? You find standard deviation variance, and covariance is how the two are related from the very first lecture. So this has connotation related to this, which I'll show you at the last slide. So, but let's try to first understand what a scatter matrix is. Is that okay? All right. So scatter matrix is defined like this. I'll show you with an example. Then in the homework we have worked out like this, and the scatter is equal to the diagonal element. We'll show all of that. So this is how it is defined. Xi is the ith row of X. First of all, you take all the data points and you put them in a matrix format where the data points are all rows. The dimension of data is D and the points are rows. So you can kind of look at this as a feature of every data point, you know, the property of the data point, which is the dimension. Okay, so what is mu? Like I said, mu is a centroid. We'll take the 2 norm squared centroid, which means that we'll take the mean value. And let's say if your X was given as 504, so these are different data points. One data point, second data point, third data point. So we define them 504, 352, 179. Then for every dimension, we find the mean. So what do? We find the mean of the first dimension, 531 by 3, 057 by 3, 429 by 3. So we get the mean vector, the mean in every dimension, correct? And then we substitute it in our value. So since there are three points, right? It's 3 dimension and 3 point as well. So we'll find the first component of the scatter matrix. So the first component of the scatter matrix is this x1 minus mu, x1 transpose minus mu from this. X1 minus mu, x1 transpose minus. This is nothing but the transpose of that, right? So it's just multiplying the two together. So you substitute as 504, 349, 345 and the same transpose, and you'll get first element. Similarly, you'll put the second element, x2 minus mu, x2 minus this, substitute and you'll get the second element. And you'll get the third element and you'll add it up, and that will define your scatter matrix. Okay? Intuitively, how far you are away from the mean. But we'll relate to variance and covariance in a minute. Before I go further, I want to show that you can write this without the summation also in this format. It's just a representation of writing this individual xi vector times writing in terms of the whole matrix. So this is not that evident. So what I have done it, you can go home, you can basically work with any. What I usually remember is the second one because it's easy to remember. I know this is x minus data, mu is my means of every dimension, x minus 1 times mu and transpose and multiplied with the same matrix again. So it's more easy to remember than the summation one. So what you want, you go home and see the homework and see how it's derived. So this is the first homework on scatter. So this is how we are showing. So we take a matrix, we work it out, and we take the other side, we work it out, and then we show that the two are equal. You can say it takes a little bit of work to prove it. It's not that evident. So you can work it out or see the homework. Everybody comfortable? Okay. All right. So we go back to the lectures. Okay. It's too big. Okay. So we showed how this is, every matrix comes, how this can be converted to this. Now what is scatter? Scatter is defined as the sum of diagonal elements of the matrix. So another way of defining scatter is this. So the scatter can also be defined in this way. So one way is that you build the scatter matrix And then when you get the diagonal elements, you add them up and say this is scatter. Another way is that you just say xi minus mu squared 2 norm, it will give you the same value. So this is something we prove here. So you take this value, put the x's value, put the mu's, substitute it in the norm, and you will get this big expression with the first dimension, first point, second point, nth point, first dimension, d dimension, second, first dimension, d dimension, first dimension, d dimension. Okay, and the way we have seen it is this. Correct? So now, oh, I've got 5 stars now. Oh, these are really big. Okay. So I got 5 stars today. So those who are asking questions, same people can get different flavors now. Okay. But you have to ask. You have to stop me. Either answer me or ask me. Yatharth ko mili hai chocolate abhi tak? You have not asked anything. Ask me, na? Okay. He is the only sincere boy in a CSC. You are also CSC? No, one in front. Are you CSC? Yeah, so they only, who else is CSC? No, undergraduate. There are many. Okay. So all girls are anyways fine. Boys are resting at home. Okay. All right. So the other way was sorry, what's happening? Okay, the other way was we had written it in this form. Now we substitute them, multiply them. Once we put xi1 to xid, mu1 to mu d, and the same thing, and we multiply, you'll get some off-diagonal elements. Right now, I'm not worried about the off-diagonal elements. I'm worried about the diagonal elements. When I add these diagonal elements, I'll get the same thing by if I had just taken xi minus 2 mu norm square. Is that okay? Everybody okay? Just basic algebra. Now the more important thing, why are we after the diagonal elements and not the off-diagonal elements? Hai na? So we'll relate this to our variance and covariance. So why look at off-diagonal terms of the static matrix? So let's say I was working in this two-dimensional space. So I had x1, x2 as the first point, 2 dimension, nth point, 2 dimension, found the mean, this average, and I substitute in my scatter matrix. Okay. So I put it in my scatter matrix. So this is xi1 minus mu1, xi2 minus mu2, and the same thing. This was xi minus mu I, and so on and so forth. Remember, this was this xi minus mu and transpose minus transpose. So we substitute this 2 dimension, I'll get this matrix. Correct? Now expand this matrix. So this expanding this matrix for all sum would be, you'll get different matrices, one matrix, next matrix, so, and element wise it will be added. So the first element of this full matrix will be x11 minus mu1 square, x21 minus mu2, the second point, and xn1 minus mu11 square. So now what is this? This is the variance of the x, except that it's not divided by n minus 1. What is variance? X minus the mu1 square, it's the summation, right? Okay, let me go back. So if I have gotten, what was the, how did you find? You said x, let's say the dimension, because I'm writing the dimension here, no, it's the first dimension, so it's different points. So if it's x, let's not use x. Let's say I've got A1, B1, A2, B2, all the way AN, BN. Let's say these are my data points, let's say. So the variance of the first thing would be how much? It will be A1 minus mu A square plus A2 minus mu A square plus AN minus mu A square divided by n minus 1 or n, whatever notation you're following. Or in other words, it's just summation ai minus mu a square divided by n minus 1. And then when you take a square root, it becomes standard deviation. So what is? It's the variance of the first dimension of the data. Correct? Everybody agrees? So what is this? This is the variance of x. And similarly, this is the second dimension. So this is, by the way, 2. So it's x12, x22, xn2. So the second dimension, this is the variance of that, because it's mu2 is the mean of the second dimension values. Everybody agrees? So what is scatter? Scatter is sum of such variances. Scatter matrix takes care of both the variances and the covariances. And now what is there in this? If you have to work this part out, so this is just the covariance. So look, x12 mu2, x11 mu1, x22 mu2, x21. So basically the product of how they are differing from each other. Remember what was covariance? Covariance we had in the very second lecture. This is what it was. So if it was two-dimensional, x and y were the dimensions. So it was, for all the data points, you're taking the product. So the same thing now, if you go back and look at into this. So you're just doing a summation and you're subtracting. So the first index is defining the point and the second index is the dimension. So the first dimension, so this is your x, this is your y. This is your x, this is your y, this is your x, this is your y. So you're just summing them. So this is finding the covariance. So what is a scatter matrix? For it's collating all the variances on the diagonal of the different dimensions and the covariances on the off diagonal elements. But we are mostly after the variances, because that is what we are going to use in designing our clustering. So because we're going to work dimension wise, x separately, y separately, z separately. So the scatter is just the sum of the diagonal elements. Is that okay? So just to summarize, because there was a lot of algebra here, so that don't get confused, the very first thing I said was that the scatter by the English name is how the points are distributed away from the centroid. Now you can define it in many ways, right? Like I said, I can define this example when I give this is night. I don't have to define this as day. I don't have to define this as afternoon. I can say this is after midnight. I mean, just a word, right? So you can define scatter many ways. One way is this. A more easier way, which is the second one, which you can see in the homework. The diagonal elements give us the variance, the off-diagonal variance give the covariance. We are usually after the diagonal elements. So we define the scatter matrix of all of this, and the scatter is only the sum of the diagonal elements. Is that okay? Now we'll come to the fact how this will play a role in clustering. So we're going to see that next. Okay. So unsupervised learning distance metric encodes the learning process, works on the principle of cluster compactness. So what you do is you basically, first of all, you don't know which point will form in which cluster, how many clusters you make. So all that is unknown to you. The number of clusters you make is typically a hyperparameter we say in machine learning, which is you play around with it and see what you get. A general thumb rule which says is if you can go from 2 to n by 2 clusters, because you want to just make 2 clusters and see what it goes, and then go up to n by 2. So if you find which is the best cluster. So if you have no idea, you will build these many numbers of clusters and see which is best. So now how do you make a cluster? Let's say you've got 2 sets of data points. What you want your algorithm to do is that make the spread of the points as little as possible within the clusters, which means you won't want the dotted ones to go as small as possible, the plus ones to be as small, and they should be as far apart as possible. So that would be something we will call as a nice clustering, that they are away and they are compact. right? So how do we define it? So we define it by the scatter itself, by the scatter matrix. So let's read this. There's a lot of content here. So it says, imagine you're partitioning the data into k subsets. The D is the data point and your D is the total set. You're defining into k sets. And μj is the mean of the dj. So have every set which you are creating, you have no idea right now, but let's say you're creating these sets and you will find the mean of that. So then there is a relationship between the scatter matrices. So which means that the total scatter of data, which you had whole blob of data points and you find the scatter of that, will be equal to the individual scatter of the clusters which you have created and the between clusters scatter. This is the between cluster scatter. This is the scatter of the individual groups. Now this looks a little foreign, but we are going to do this example. So if you look at the same example which I had drawn earlier, let's say this was, so if you took all the data points together, all the dots and B pluses together and found the scatter matrix, then it will be equal to the individual scatter matrix of this, and a B matrix which we are calling as the between cluster scatter. Now between cluster scatter is, how is it built? It is built by replacing every point in this cluster with its centroid value. So let's say I had 4 points, I'll find its centroid and replace those many centroids, 4 centroids. This had 4, I'll find its centroid value and replace it with 4. And I'll build this between cluster scatter. Is that okay? This will be clear because we are going to do an example. But this relationship which I have drawn here, I'll show you towards the end. It's done in the homework as a proof, so that you can know this actually exists. Now what I'll do, I'll show you with an example. Okay? So that it gets clearer. So, okay. All right. So consider that you have got 5 points, 0, 3, 3, 3, 3, 0, minus 2, and they're saying that they are centered around 0. So how many data points are there? 5. So your n, which is the cardinality of capital D, the D set is 5. The dimension of data is, small d is 2. Everybody with me? Now we have to build S, the scatter of whole of it. So we are going to build this left hand side. Is that okay? All right. So to do that, so this is written star here, C star, so we'll go bottom. So X is this. Now the mean is already given to you as 0, 0. But you can actually add them up. This is 6 minus 6, this is 6 minus 6, so it's all zeros. The mean is already given, but you can also compute. Like I said, it's easy for me to remember this formula, so I'm going to use this. Now, what is mu? 0, so this will be nothing but X transpose X, correct? So we'll just substitute the X transpose times X. Remember, this is transpose and this is the original matrix. So we're going to just substitute it. Once we substitute, do the computation, we'll get 2 cross 2 matrix. And the trace of that turns out to be the scatter is 76. Okay, pehla part okay. Now what it says is, if we cluster the first 2 points in one cluster and the remaining in another cluster, then what happens? So basically out of these 3 points, we are saying this is cluster 1 and this is cluster 2. This is all random at the moment. It's all random. So what we do, we'll find the scatter S1 of the first cluster, the scatter S2 of the second cluster, and then we'll find the between cluster scatter. They have to be equal. S should be equal to S1 plus S2 plus B. So let's just do this computation. So this what I have written is written 2 star because they do it very small. I have worked it out here. So this is 2 star. These 2 points are belonging to the first cluster and these 3 are belonging to the second cluster. Okay. Now what is the mean? 3 by 2, 6 by 2. 3 by 2, 6 by 2. So the mean for the first cluster is 1.5 and 3. Correct? So we go to substitute it this 0303x minus 1, which is a vector of 1s, minus mu transpose, the whole transpose in the same matrix. Again, I am going to skip the algebra. Okay? And you get scatter as 4.5 or the trace as 4.5. Okay? We'll do the same thing for the other matrix. Okay? The other matrix is, other set of data points are these. What is the mean of this? Minus 4, minus 2 plus 3. Minus 3 divided by 2 by 3. It's minus 1. This will be minus 6 divided by 3, which is minus 2. So minus 1 and minus 2. So we do it for the second one. It's minus 1, minus 2. Substitute in the expressions. 3, 0, minus 2, 1, 1. This is the mu value. Transpose the whole thing again. And then you get this, the matrix as this. The scatter would be just this, which is 34. Okay? So what we computed S, we computed S1, we computed S2. Now we want to compute B. The B is the between cluster scatter. To compute B, we said replace every point in the cluster with its centroid value. Okay? So which means, so ये workout हो गया, अब B के बारे में हो रहा है यहाँ पे. So B is worked out like this. So we're going to draw the B, which is 3 star here. It's written C3 star, so it's here. So recall, for the first cluster, the mean was, centroid was 1.5 and 3, and the other one was minus 2, minus 1. Now the way to compute this between cluster scatter is replace every point in that cluster with this mean value. So there were 2 points, the same mean value, 3 points, same mean value, 3 copies and 2 copies. Everybody with me? So now what we do is, of course, the mean of the whole thing is going to be 0, 0. You can compute it also, minus 3 plus 6 minus 6, it will be 0. We're going to again substitute this into a formula. Now x minus 1 times mu transpose, the minus 1 mu transpose will be 0. So it will just be xb transpose xb. Everybody with me? Yes or no? So what happens now, we do the computation and you get the trace as 37.5. Now add this, this is 37.5, this was 34, and this was 4.5. 37.5 plus 4.5 is 42, 42 plus 34 is 76. What was the overall S? 76. This is an example I have shown. In the homework, I have worked it out. But why are we doing all this? Which will be clear again with another example, with the second part of this example. So before I go that, let me show you the proof of this, so which is worked out in the homework. Okay, so interaction. So this is where we prove this. To do that, we have, in this case, we have taken a 2 cross 2, 2-dimensional 5 points, but you can do it for general as well. For that, you may have to use induction, but you can prove this. So you can show this for the general case that it works. Okay, going back. Now what we'll do, you will do some computation with me so that this gets more clearer to you. Okay. So now what we'll do, we were at this example. So now what we'll do is, we'll go to alternatively we'll treat the first 3 points as cluster and put the other 2 in the second cluster, which I have worked out. I think I've worked out late. I've not worked out. So you work out with me. So earlier what we had done, so the total scatter will remain same because the set of data points are all together computed, the scatter. Now instead of, so earlier we had taken these 2 in the first cluster and these 2 in the second cluster, and we found S1 as 4.5, S2 as 34, and B as some value 37.5, right? So those are the values which we got. Now what you want you to do is take the first 3 point in the first cluster and the last 2 point in the second cluster, and now you find S1, S2 and B values. Can you find at least one so that we can work it out further? This is written how scatter is defined. So for the first 3 points, it will be 0, 3, 3, 3, 3, 0, 0, 3, 3, 3, 3, 0, minus 1, 1, 1. And the mean value of that will be 3 plus 3 is 6 divided by 3, 2, 6 divided by 2. So 2, comma 2. And that's it. So then you'll find your S1. So tell me the trace of S1 in this case. So now your X is 0, 3, 3, 3, 3, 0, minus 2, minus 4, minus 4, minus 2. And we're saying we're going to put these 3 in cluster 1 and these 2 in cluster 2. So now we have to find all of the things. We have to find S1, S2 and B. We have to find all of that. So to find S1, this will be 0, 3, 3, 3, 3, 0, minus 1, 1, 1, and then the mean of this is 2 and 2, and this transpose times same. Has anybody computed it? Sorry, what did I do? We're saying we put the first 2 points in one cluster, remaining 3. This was later. Then we are putting alternately with the first 3 points in the first. Does it come out to be this 6 minus 3 minus 3, 6? Has anybody done it? Do you want me to do it with you? Zero, 3, 3, 3, 3, 0, minus this will be 2, 2, 2, 2, 2, 2, transpose and the same thing. So this is equal to, so this is minus 2, 3 minus 2 is minus 1. 3 minus 2 is 1, 3 minus 2 is 1, 3 minus 2 is 1, 0 minus 2 is minus 2. Hai? This transpose this, so this is minus 2, 1, 1, minus 1, 1, minus 2. This multiplied with minus 2, minus 1, 1, 1, 1, minus 2. So everybody with me? Now we'll multiply, we'll get a 2 cross 2 matrix. So this is 4, 5 and 6. 2, 3, 3 minus 2 is 1. 2, 3, this will be 1. 1, 2, this is 6. So the trace of this would be 36. Trace of this is 36. Everybody with me? Who कर लिया किसी ने किया? Sorry? Sorry. I'm multiplying it. So the trace is to be added, so it's just 12. ठीक है? अभी इसी तरह S2 निकालेंगे. So when you compute the S2, what do we get? हाँ -3, वो -1 कैसे लिख दिया मैंने? ये गलत लिखा है क्या? 2 1 1 +2 3 +2 3 and 3 अच्छा ये +1 है क्या? हाँ करेक्ट, ये वहीं से गलती चल रही है. ठीक है चलो, doesn't matter. So where were we? So this becomes 3 and 3, यही है क्या? 3 3 है, -3 है, -2 and 1 and -2, हाँ -3. ठीक है. So you'll do the second one, which you can now easily do S2, and you will get values as 2 2 2, all 2's. So it will be 2 -2 2 -2 2. So the trace in this case is 4. And then when you compute the B value, can you compute the B? Because that's a little confusing, and tell me what you get. We have time, that's why I'm making you work. Shivam, come. I have to finish this. Yatharth, you have to answer me now. I have to give you a chocolate. Girls here. This side, girls. What are your names? Niranjana and Nishika. Rishika, okay. Niranjana and Rishika, I want next answer from you. I have to give you chocolate. This side, anybody who answers, then tell me. So to compute the B, what we'll do, we'll take the medioids. So the medioids in this case were 2 2 and -3 -3. So what we'll do, we'll replace the x value. So xb will be 2 2 2 2 2 2 -3 -3 -3 -3. Correct? This is what we'll do. Because those are the means. Those are the first 3 and these are the next 2 cluster. And what is the mu values? Which will be 0, 0. It's obvious because you're playing around with the same points. So now what will be your B? It will be nothing but xb transpose xb. So once you multiply, so this will be 2 2 2 -3 -3 2 2 2 -3 -3 and 2 2 2 2 2 2 -3 -3. What do you get, Yatharth? Tell me the matrix. All 34? So the trace is 60. Okay. Now add it. 60 and 16 makes it 76. What was the original one? 76. Come, Yatharth, one for you. Now Niranjana and Rishika, question for you. You will have to answer me. Okay, now let's look at the 2 cases. The first case was, of course, the S in both the cases was, the trace of S in both the cases was 76, so we're not worried about it. But we want to look at the other cases. So case 1, the trace of S1 was, tell me, 4.5. Trace of S2 was 34 and the trace of B was 37.5. Case 2, The trace of S1 was, what was it? 12. The trace of S2 was 4 and trace of B was 60. Okay, so those are the two cases. In the case 1, the first 2 points were in one cluster, the remaining 3 in the different cluster. And in the second case, the first 3 points were in one cluster and the remaining 2 in the other cluster. Correct? Now, Niranjana and Rishika, which one is a better case? And why? Okay, still thinking. This row, which one is a better case and why? Orange shirt, orange t-shirt, yeah. Okay, this row answers the most. That's why I'm coming late. This one, case 2, why? Correct. What did we say? What was our goal? Our goal was to make each cluster compact and far apart. Come. Look, you missed a chance of 5 star. Kept thinking. Huh. We can do that as well. Correct. You don't have to do this. You're right. If you have S, you can use that. Okay. So like, what's your name? Rupa? Okay. So what she just mentioned, in this one, if you look at it, if you add the 2 traces, this becomes 38.5. And if you add these 2, it becomes 16. So these are more, you can see, I mean, although in this one, the value is slightly getting increased, this cluster in this case is getting more spread out than compact in the first case. But overall, if you look at the 2 clusters, the sum values, they are, if you are to look at it in the case 1, so if I had to draw the case 1, I would say that, these are really close and these are very spread apart. But the gap between them is this. This now relatively, if you look at the second one, you may see that they are little more spread out than the first one because 4.5 becomes 12. But when you look at the second one, it is, like this. So these are this and they are more far apart because the gap is 60. This is more compact. This is very spread apart, but the gap between them is 37.5. So I would prefer the second clustering because that looks like both are, you're trying to, play around with 2 objectives, make multiple objective, not even 2, because the number of clusters, each of them getting compactor and they getting far apart. Imagine there were 3 clusters. Then you will have to worry about more objectives, that all of them should be far from each other and they should be as compact as possible. Is that okay? Everybody comfortable? Okay. So we're going to stop here today because the next lecture is about the algorithm, but I'll give you a primer of this. So what the next part now we're going to do is that now we're going to develop an algorithm which implicitly tries to do this. What does it try to do? A K-means problem is to find a partition that minimizes the first term or maximizes the second term. Ideally, you would want to do all of them. Ideally, you would want to make them as compact as far, but you may not be able to do it all the time. So the algorithm which we are going to do is going to mostly try to make each cluster as compact as possible. So what it will do, it will try to minimize the scatter as much as possible and iterate. But the only thing you should know is the number of clusters you want to create. Like I said, that's a hyperparameter you don't know. And if you have no idea, you can go from 2 to n by 2. If n is the total number of data points, that's a heuristic which you would use. But assuming that you have been given that you split this data into these many clusters, your algorithm will now try to find the points in those many clusters so that the within cluster scatter is minimized. Is that okay? So we'll see this algorithm tomorrow, which is k-means. A variant of that is k-medioids, which you would have guessed. If you replace the centroids with the medioids, it becomes k-medioids. And there is a lot more analysis to it. So that is how we're going to finish this part. And then once I do that, then you can do all the problems in the tutorial, in the practice, and then we'll follow it on Friday with the Thursday with the example. Yeah, that's it. Thank you. I finished slightly early today.